Okay. Uh, in this section, we are going to discuss about agriculture water management and drought monitoring. So there are two type of codes we have, one for drought monitoring and another is for crop water stress index. So this crop water stress index is generated by me and Ashutosh Singh for monitoring the for irrigation water management. So in this code, we have developed a third code using the NDVI and NDWI formula. Earlier, you have seen in the previous classes, in the previous training lectures, NDVI is used for monitoring the crop health. As the crop is healthier or crop is growing, the NDVI value is increasing. And NDWI for water, there is two type of NDWI value. One is for water and another is for crop water stress. So by using these two values, we have created a third index as a crop water stress index, NDWI, adding both the indexes NDVI and NDWI. The result for this uh, code is this formula is very good. I will display you. Let's discuss this. As we know, the NDVI has value from -1 to +1 and NDWI is also has value from -1 to +1. When we add both the images, the value becomes -2 to 2. So for that, we have classified our image less than 0 in NDVI or NDWI. That denotes the water pixels or water body area. So we left that. And from 0 to 2 value, we have utilized for monitoring the crop water stress. So when the value is greater than 1, means NDVI and NDWI both have value that has been greater than 1, that is in the class 1 as a non-stress vegetation. And when the value is greater than 0.8 and less than 1, then it represents the low water stress. And in third, the value is less than 0.8 but greater than 0.5 because vegetation has value greater than 0.25. And by adding both the data, when we get the value is greater than 0.5, so it has moderate stress condition. In group 4, the value is less than 0.5 and greater than 0.35. So the field is captured with the or covered with the crop because we have taken the NDVI value always greater than 0.25. When we add the data, but we have given one condition. The NDVI value should always be greater than 0.25 to monitor the agricultural field. So the NDVI value is greater than 0.25. When we add NDVI with NDWI, the value should be always greater than 0.35. And in group 5, the crop water stress index is when it is less than 0.35, then it is known as the severe stress condition. So this is our paper, which is published in American Journal of Remote Sensing. So you can go through that to see. And another one is for drought monitoring. So let me discuss first one, then go to the second one. Here, see the results firstly. So this image is for February month 2020, from 1st February to 15th February. We can easily see in the Punjab region. As we know, the Punjab region, Punjab and Haryana is irrigated area. Mostly fields are irrigated and canal network is very good. And there is more irrigation process is running in this area. So there is no stress condition can be seen in the Punjab and Haryana region in place of other region. And in Indo-Gangetic Plain, we know the most of canals, river and water facilities are available in the Indo-Gangetic Plain. So in Uttar Pradesh, Bihar, Jharkhand, there is low, moderate to high stress, but not much the severe stress condition. But when we move towards the southern part during the February, because it is non-monsoon period, and in this season, the area is totally depending upon the canal water. So there you can easily see the moderate to severe stress condition. Only few regions have the low stress in this area and no stress in the coastal parts of this region. So for irrigation water management, when we have no stress, then we don't need any type of irrigation, because in Punjab and Haryana, farmers used to give more irrigation, and in Uttar Pradesh also. If their field is already have water, but they are giving more to more water, that is not good for the plant health also. But when we have low to moderate stress, then we can, when we have low stress, then we can shift our irrigation from 5 to 10 days to 5 days, or depending upon the crop. And when we have moderate to high stress, then we have to immediately irrigate our field to get the higher yield. But if there is severe stress, then we need some type of further cultivation or any further recommendation for farmers. So we have to provide some help facility to the farmers for monitoring the stress condition and giving the irrigation facility. So for irrigation management, we have used this code. So let's start for the code. So here we have called the ROI India, our area of interest, to show the different part of India. Variable add image. This is our variable function image. Variable minimum. Here we have given the Sentinel-2 image. Just call the Sentinel-2 image in line number 2. Then filter date. As you know already, this is for February 1st to February 15 for 2020. Then function image, variable min. We have taken the Sentinel-2 minimum value for that period, because minimum value give us more clear sky. When we took the maximum value, it will, because in electromagnetic spectrum, if there is any white patches on the earth surface or cloud is there, then the sunlight is totally reflected back. It will capture by the sensor and it appears white in the image, as I shown in the flood imagery. You can easily see the cloud as a white patch. So removing the cloud, because we don't know which image has cloud and which image has not. So we took the minimum, because minimum giving the more reflectance of the earth surface. Then variable result, minimum, that minimum called here. Then select their band, that is sphere band, NIR, red and green. Then variable result, we have taken this image dot clip ROI. We have clipped that area with our region of interest as India. Then return image. We have returned to the image, then added it into image. Then variable S2 with image. Then S2 with image. We have mapped that image in that image. In Sentinel-2 data, we have mapped that function, that image which is called with this function add image. So we map that image. So this image is also added in the Sentinel-2 imagery. Then map.center object. It is for centering. The zoom level is 6. Map.add layer. S2 with image. Then I have added that Sentinel-2 imagery, the computation timeout, because for India, the lots of data is processing. So it is showing some error. So maximum for displaying the Sentinel-2 imagery, this parameter is given maximum 3000, because Sentinel-2 imagery, for displaying the Sentinel-2 imagery, maximum value is given 3000, as I shown for the microwave region. Variable minimum, S2.min, as I said, we have taken min for removing the cloud. Variable result, minimum.select, then again I have selected the imagery. Then image1 result keep ROI. Actually, it is again repeating. I did not see. Okay. Then I have calculated the NDVI. NDVI, as you know, the normalized difference index. The 8 is NIR and 4 is for red band. And here NIR minus swear band. Band 11 is for swear band. The variable CWSI NDVI dot add NDWI. We have added both the imagery. As I said, I have used CWSI by using both the indexes. Then no stress. CWSI is greater than 1 and NDVI is greater than 0.25. As I said, I have always used the agricultural land for irrigation management, and agriculture or vegetation is calculated in any field. The value of vegetation is always greater than 0.25 in NDVI. So the value is always taken as a greater than 0.25. Then low stress CWSI is greater than equal 0.8 and less than CWSI 1. So less than 1 and greater than 0.8. Then greater than 0.5 and less than 0.8 is moderate stress. For high stress, greater than 0.35 and less than 0.5. Severe stress, it is less than 0.35, but there should be vegetation. So the NDVI is greater than 0.25. Then again, I just only did multiplication. For no stress, multiply 1. If I remove this, there is no need for this. It already gives 0 and 1. Then multiply 2 for low stress, multiply 3 for moderate stress, 4 for high stress, and severe stress, it is 5. Then I have added all the imagery. So this crop W image is become value with 0, 1, 2, 3, 4, and 5. 0 is for non-crop. Where is the crop? No crop. So it will become 0 like this area. There is no crop in the field. So it will become 0. Then 1 with no stress, low, moderate, high, and severe. So variable crop is for that. Then we have created this legend panel. So this is for creating that panel. I have already discussed about it, how to create. Then crop water stress. These are the labeling. Then make row. Then we have given some color here. So I think in previous classes you know, but let me discuss. So this is the function color, then name, color box, UI.label. What is the label? Color, padding 8 pixels. So it will take the 8 pixels. Then margin between this is that is decided as the 4 pixels. Then variable description UI.label, value name that is called from there, and style margin. So the margin between the variables. Then return UI panel, which is color box. So the color box, this color box will come. So UI.panel layout flow horizontal. So the flow is horizontal, like in the color box in left and the name is on the right. So this flow will be horizontal. Then palette, the color of this. So for non-vegetation, no stress, low stress, moderate, high, and severe. This color is taken from, color code is taken for that. And then according to the classes, the color code is given, and then according to their classes, the name is already given. No vegetation, no stress, low stress, moderate, high, and severe. That is displaying in this panel. So now how many variables should be displayed here? So for that, this function is defined for variable I equals 0. So minimum value is 0 and maximum is 6. So here are 6 classes. 1, 2, 3, 4, 5, 6. So that's why here 6 has been given. Then I plus plus. So this will add these classes. Then legend dot add macro as defined in the macro palette. This palette and names. This palettes and name will define here. Then map dot add legend. In this map panel, this legend panel has been added. Then map dot add layer, crop W1. Then minimum is 0 and maximum is 5. as the color code is given here, that is already copied for there, and the name is CWSI. So this is for irrigation water management, when to irrigate our crop. Actually, we have Sentinel data that is on the 5-day interval. So when there is no cloud, so we can monitor it. For that, for irrigation water management. So this code is for irrigation water management. Now let's go for the drought monitoring.
Yeah, Pragati, before going ahead, you are filtering the Sentinel-2, that is optical data, for 15 days in the second line.
Yes, sir.
And
Yes.
then you have calculated for that period, means you have used NDVI NDWI value for what period? Means you have
Sir, for
averaged
that period, for
like
this period.
you
for
have
February.
taken mean. You have taken mean of.
Yes, sir, because it has 3 images. Because
Okay.
Sentinel is available on the 5-day interval.
After every 5
So,
days.
for taking whole India mosaic, because there are some cloud in some parts of India, not whole India is always clear.
Okay.
So I did some exercise to make whole India clear imagery. So I have taken this time period. Otherwise, when in our app we did not filter it with mean, because when you have imagery, the value will be displayed in our app that is shown in spacefund.org. But for displaying here the whole India, for an example, I have filtered for 15 days.
Okay. And one more thing, no vegetation. How have you selected? Means you have removed.
Before less than value 0.25 in NDVI, that is denotes as a no vegetation.
Okay. Then what about the forested area which will be having NDVI greater than 0.25? Can we?
Yeah, sir. For that we have to use some mask, because forest is always mixed with the agriculture area.
So that is done,
just
or
the
you have?
example code.
Okay,
Sir,
we have to do that.
Sir, I
Okay.
have a mask for India.
Okay. So are there any queries regarding this?
Sir, shall I move?
Yeah, go ahead.
So for drought monitoring, I have used that manual, which is already available. So using this manual, I have just utilized 3 to 4 formula for monitoring the drought. So there are some different indexes like normalized difference vegetation index, NDVI, NDWI, and NDVI deviation and NDWI deviation. In NDVI deviation formula, we have to monitor we have to take the mean of 3 years consecutive NDVI for any particular week or for any particular period. So NDVI denotes the recent data, but NDVI-N is the mean of 3 years NDVI for that consecutive period. Like we are taking from 1st August to 7th August. So from 1st August 2015 to 2017, the mean of that data is taken as a NDVI-N, then divided by N and multiply it with 100. So NDVI deviation is that, NDWI deviation is again for that. Then moisture adequacy index, that is denotes as a MAI. It has the formula AET divided by PET into 100. So we have used that data. Then rainfall deviation. Rainfall deviation is again for 30 years. The method is same. This is current. This is for 30 years average rainfall for that particular time period. So how we declare the drought? When the rainfall is 19 to minus 19, that is normal period. But when it is minus 20, the deviation of rainfall is minus 20 to 59, then deficient rainfall. Then minus 60 to minus 99, then large deficiency of rainfall. And when it is less than 100, or when it is 100, less than 99 and it is 100, then there is no rain. So and a standardized precipitation index is again for that. And we have used the VCI. VCI is like NDVI deviation. It is again for 10 years. As in NDVI deviation, it is for 3 years, but for VCI, it is for 10 years. And MAI, when we have divided 80 by PT and multiply with 100, when the MAI value is 76 to 100, then there is no drought. But when the value is from 51 to 75, then mild drought. 26 to 50, it is moderate drought, and 0 to 25 is severe drought. So using this, then how to declare the drought? So mandatory indicator is rainfall indices. From both the indices, you can take one indices. So I have taken rainfall deviation. Then the second is the you have to take the three impacts. One is mandatory, that is rainfall. Then other two are depending upon your choice. So you can check hydrological, because I don't have any hydrological indices, hydrological thing. So I have taken this remote sensing thing for showing. So agriculture, crop shown area, you can check the crop shown area by taking the NDVI value greater than 0.25 for any time period. How much the area is shown under the crop. Then remote sensing indices, VCI or NDVI deviation. Soil moisture, in soil moisture you can use percent adjusted soil moisture index and MAI and hydrological model. So the states may consider any three of four types. You can take any three of four. So how we declare severe drought? If all the selected three impact indicators are in severe category, like rainfall, crop shown area, VCI, PSM, or anything, that all are in three, all have the severe category, then it is severe drought. But if the two are selected in the three, in the moderate or severe class, then it is moderate. And if there is in other two are in low or non-drought condition, then it is normal for all the cases. But finally, it is depending upon the local knowledge and ground truthing to declaring the drought. So ground truthing is most important, but this is the parameter for monitoring the drought. So let's move for the drought. Firstly, let me clear one by one. So I have created for MAI. So for that, I have taken, for just example, I have taken already provided NDVI with MODIS data. So for that, NDVI, MODIS. So MODIS NDVI is already available. So I have taken 250 meter MODIS NDVI. Here the NDVI is already provided. So I have taken this. And one more thing, let me show. One thing should be considered, the scale. The scale factor is given here. So scale factor is for resampling the image. So here is the scale factor is 0.0001. So we have to multiply this value to get the NDVI value from 0 to 1. But they have multiplied it with the 10,000 to increase the value. So for getting value 0 to 1, we have to multiply it with 0.0001. Then I have imported the variable ROI from my asset and center object. So variable collection, image collection, this is called from here. So I discussed in the previous code. I have copied the link of code from the code section, but here I have imported the data. So by using both the technique, you can import the data in your code panel. So image collection, here variable is image collection dot filter date 2021 from July. For July month, I have chosen to monitor whichever area is affected with the flood using the MAI. It is only one indicator. So I will discuss one by one. So for that, I have created 4 code separately, then merge it into one code. So this is for MAI. So for July month dot mean, I have taken the mean value because the average value of that period, then click ROI. So the mean of actual evapotranspiration and potential evapotranspiration has been taken. Sorry, this is for MAI, not for the NDVI. I discussed wrong. PET. Okay. So this is 500 meter 8-day global. What is PET? So there is the band. So ET is for actual evapotranspiration and PET for total potential evapotranspiration. So I have used this ET and PET data for calculating the MAI. So this is imported from there. So AET, or you can call it as ET. ET. So ET. Collection.select ET. So I have selected from this collection, from this image collection, the band ET. And in PET, I have selected the band PET. Then what is the function for MAI? What is the formula? AET divided by PET. So ET is for actual evapotranspiration. So it is divided by PET, then multiply it with 100. So using that, the MAI map has been generated. See, this is the MAI map. It has value 0 to 100. So I have given red to green. So green has no drought condition. And the false value, I have clicked here to show the map. See, reset and run. When I give here false means the map will not directly open. See, this is not checked. When I checked it, then the map will display. So for that, I have given here the false in the map.add layer function. Now I am going to classify the drought condition. So no drought when MAI dot greater than 75. So I have multiplied the AET dot divide PT with 100 to make the value 0 to 100. So MAI dot greater than 75 is no drought condition as shown in this formula. AET divided by PT into 100 and MAI greater than from 76 to 100. So greater than 75. Because in mild drought, it is 51 to 75. So there could be possibility to value for 75.12345. So we cannot take 76 directly. So I have taken greater than 75 value. So greater than 75, then 50 to 75 is moderate drought. And again multiply with 2 to give it value 2 for making a single band image. Severe drought, MAI dot less than 50. It should be less than 50. So there are 3 categories in the formula. So I have taken this 3 category: no drought, moderate, and severe. One is left. Oh, one is left. See. And 25. Mild, moderate, C. This is for mild, moderate, and now we are going to make the severe drought. This is then equal to 25 and multiply it with 0.
Change the name
Yes.
of the variable also.
Yes, sir. Okay, then add here one more. Okay, so I have added all four.
S severe drought, one at one place it is small and another place it is capital. You can make it capital S.
Yes. Okay, thank you, sir. So let's run it, reset and run. So there are 4 categories for declaring the drought using MAI, but using one category we cannot declare the drought. So we have to use at least 3 categories. One is rainfall is important, and another 2 is depending upon us. We copy first because I copied all the code in this. Save. There. If anyone have some question, Asu sir will declare clear it. Let me do it.
Meanwhile, I will just add few things. Actually, the drought manual is brought out by Ministry of Agriculture and Farmers Welfare. In the drought manual, there are many indices which give an indication of drought. The indices based on rainfall deviation, then based on vegetation like NDVI, VCA, vegetation condition. So based on those vegetation indices, they have defined some indices based on NDVI, and based upon what reservoir storage level, they have defined some indices. So to declare a drought, it cannot be any one singular index. We cannot rely upon that. Like even if rainfall there is deviation, if the previous year if it had a very good amount of rainfall and there is good storage available and the vegetation condition is good, then even if there is some deviation in rainfall, it is not actually a ground condition, drought condition on the ground. So we have to use a combination of these such indices. I think she has translated the indices which can use remote sensing data. She used the same formula and she has created the layers using Google Earth Engine.
So for MAI, this is the result. Let it come. So for MAI, only for MAI, this is for drought region. There is no drought, there is moderate drought, and there is some not drought condition. So this is red, yellow, green. is displaying blue, green, yellow, and red according to the no drought, mild, moderate, severe, and drought condition. So these are the categories using only MAI. Then we have, let's move for NDVI deviation. For NDVI deviation, what I done, that is, I have filtered out for 1 month. For July 2018 till August 2nd by using the MODIS NDVI imagery. Here I have used MODIS NDVI, which is already provided here. So I have imported, as I said, that data and use as a image collection. See this data. And it has already banned NDVI, and I said the scale factor. I had already said about the scale factor. So here you can see the maximum value is 10,000. 1 to 10,000. So it is multiplied with 0. So make it 1. We have to multiply it with 0.0001. So image collection is called here. So for NDVI deviation, as I said, we have to take 3 years mean or average for 3-year data, previous 3-year data, and then subtract it with the current year and then divide it by the last 3 years data and multiply it with 100. So for doing this, I have taken for 2018, 19, and 20 from July 1st to August 2nd, because it is August 21st. So maybe the data will be not available clearly. So I have used for this time period. Then for that, I have taken the NDVI, that select NDVI, then mosaic, the data for India, and then clip for ROI. That is our India boundary. Then make the composite of these 3 images. I have added all the 3 images has 0 and all the 3 images has NDVI value. So I have added all the values. Collection 1, collection 2, and collection 3. Then divided by 3, because there are 3 images. That is not the image collection. When you ask me for making the mean, dot mean. So dot mean function is only for the image collection. I am not making here image collection. I am adding all the images. So dot mean function will not properly not working here. So I have divided it by 3. Then print function has been used for printing that data. Then collection, here I have taken the recent period for July 21 to August 2nd. Then again selected the mosaic. The same function is in this line. For variable NDVI deviation, collection dot subtract this composite image for average of 3 years, then divide this composite and multiply it with 0.001. As I said, the scale factor is 0.0001. So when I make it 0.1, so it gave me value from 0 to 1 range. But
no, Pragati, yes. I think it is it the scale factor, or is it we have to using the formula?
Sir, both, using the both. In the
scale factor, because we have anyway the numerator and denominator, scale factor will be there.
So yes, scale factor will be there. So that's why I have multiplied it with 0.01. Because sir, NDVI has values. So for that, when we use the denominator, again the value is coming from between 0 to 1000 or 10,000 like this. So for making it 0 to 100, we have to multiply it with 0.01. So then map dot add layer, the minimum value is -100 and maximum is 100. Oh, maximum is 0. Oh, sorry. Sir, you are right. Minimum is 0. Denominator is there. Actually, I was doing some exercise with this. we don't need to do the scale factor here because we are using the denominator. Let me check one.
But in percentage terms, what is the formula of the deviation? NDVI deviation. You can have a look once.
Yes, sir. Sir, let me see once. NDVI deviation.
Previous slide.
Sir, in this line.
No, in your
Yes, sir.
presentation. Go to previous slide, slides number 6.
Sir, this one.
NDVI current value minus average of last 3 years. Is it so?
Yes. Yes.
Divided by and we have to multiply by 100. Yeah.
Yes.
So you are implementing the same formula there. There will
Yes.
not be any scale factor because we have NDVI both in denominator and numerator. That multiplication is only because of that 100.
Yeah, this is the image. Yeah, this one. So it has value. Let me show you. The NDVI deviation is minus 40. So that's why I have taken here minus 100 to 0 because I am taking the deviation from NDVI. When it is 0, when it is greater than it is 0, then there is no deviation. So we are making the deviation. That's why we have to use there minus. Sir, I forgot to add the formula like for VCI deviation I have used, but forget to.
Yeah, actually
what
it's
is
okay.
the value for monitoring that? So that's why there is confusion. So for deviation. Okay.
So red portions are those where there is maximum deviation.
Yeah. So for no drought, when the NDVI deviation is greater than minus 20. So for minus 20, greater than minus 20, so there is no drought. And for NDVI deviation, and then for moderate drought, it is less than minus 20 and greater than minus 30. And for severe drought, it is less than minus 30. And then multiply it with 3. Sir, it is minus 30 to 50. I forget one again. So it is minus 30 and
Anyway, no issue because it is formula. We can get it connected afterwards.
I forget one thing. So this is 3 and let me do 4. See. One for moderate one, 30, 50, okay, 3 less than minus 50. So this is for mild, moderate, and severe drought. So let me add one. Add. So there is value 0 to 4 coming in the image. So this is an example for monitoring the drought. So this is for the NDVI deviation drought. So this year, most of the region of India is not affected with the drought using the NDVI because the NDVI is very good. But in the some part of Madhya Pradesh, Bihar and West Bengal, there is a drought-like condition for July month. So using the NDVI parameter, we can see the drought condition in India. Let me copy it and again paste it in. I will paste it in the. So using the same these parameter, I have built this drought code. In this code, all the parameters for drought is given. There is MAI. This is the NDVI deviation. Actually, I have given here underscore N because in all the previous code like NDVI, MAI, I have given the same name. So running with the same name in the code is not possible because it will give you wrong value. So I have given the different variable name. This is the NDVI deviation formula for monitoring the drought. Let me save it. And let's move for the rainfall deviation. So for rainfall deviation, this is same like NDVI. I have used the CHIRPS daily rainfall data with the station data. So it has band, precipitation band, and the maximum value is 1072.43 mm. So you can directly import it or copy it from here. So like that, I have imported the data and the ROI is already there, then filtered it for July month for the same period. I have taken the same month from July 1st to August 2nd. So for that, I have taken 30 years of rainfall data. So here the 30 collection has been generated. Collection 30. See, from collection 1 to collection 30. Then selected the band which is known as the precipitation band. And for rainfall, we have to make the sum of rainfall because the rainfall is cumulative for that particular month. So dot sum function is used for making the sum of rainfall for the India for that particular time period. Then dot click ROI. Okay. So this is the 30-year period. Then again, I added all the data and then make the average for that by dividing it with 30. See, by dividing it by 30. So I made the 30-year average in the variable compo. The recent year, July month from August 2nd data, the same function. Then the formula as shown in this section, rainfall deviation. like NDVI deviation, the rainfall deviation is again rainfall for current year, then 30-year rainfall minus 30-year rainfall divided by 30-year rainfall average and multiplied it with 100. So using the same formula and multiply it with 100, the rainfall deviation has been calculated and the minimum value is minus 100 and the maximum is 20. So as you see in this formula, the rainfall deviation from normal year, it is minus 19 to 90. This is normal period. So using this method, I have used the rainfall deviation. So no drought means normal period. The rainfall deviation is greater than minus 20 and the rainfall deviation is less than minus 19. So minus 20 to 90, 19, that is no drought. Then low drought, rainfall deviation is less than minus 20 and greater than minus 16 as it is shown in this figure. Then 16 to 99 and less than 90 and equal to 100. So 60 minus 60 to 99 and then less than 99, or you can just give it 100 or EQ 100. Then multiply it with 4. So 1, 2, 3 and 4 imagery will prepare for rainfall deviation and the drought is added, then 0 to 4 value is given there, then reset and run. So using the rainfall deviation, you can easily see the most of the region is coming under the category number 3. Green is for no drought, yellow is for low, and orange is for moderate drought. So most of the India has less rainfall than the average. In the place of some part of southern part of India, in Tamil Nadu, there is a severe condition, and here is some moderate rainfall condition. But all over India is coming under the moderate rainfall, moderate drought condition using the rainfall parameter. But we have some irrigation facility available, so we cannot declare it as a rainfall drought period because we have source of canals, source of many irrigation facility, wells or etc. So directly we cannot declare this year as a drought condition. So using all the 4 parameter, we will declare as a drought, moderate drought or severe drought condition. So now we are moving to the VCI. So for VCI, this is again NDVI average for 10 years. This is 10-year average NDVI. Here I have multiplied it with 1. Let it make 100. Okay. The same formula is given here like NDVI deviation, only it is for 10 years. The same VCI, for VCI, let me check what is the value. Yeah. VCI value is 60 to 100, that is good. 40 to 60 is fair and 0 to 40 is poor. So it is change it. VCI 60 to 100, so greater than 60 and less than 60 and greater than 40, and that is less than 40. I have copied it from NDVI deviation. That's why it is showing this value. Then drought condition is declared using the same formula. So using the VCI, most of the part is coming under the red, means it has the severe drought. So while using a single parameter, we cannot declare the drought. So we have to use all the parameters to declare the drought. So in this drought formula, so this drought is for, this is for rainfall, 30 years rainfall. I have make it composite. Then MAI is here. Then NDVI deviation. Then multiply it with 100. Okay. Then this is for VCI. VCI. Let me copy it from here. Make it greater than 60. Less than 60. Greater than 40. See. So I have used all the parameters. Then for drought declaration, I have used, as I said, all the parameter has severe condition. So rainfall, I have taken, this is mandatory, then VCI and MAI. I have not taken the NDVI deviation in this board, but I have taken NDVI deviation in the other one. So using all the parameters, you have to declare the drought. So VCI equal 1 and MAI equal 1, then it is no drought condition. So there is no drought if all the parameters have no drought. But if all the parameter have drought, like all the parameter has value 3, then it is declared as a severe drought. Then if one parameter has the drought like condition and other has not, then it comes as a moderate drought. So okay. Multiply So for declaring the drought, we have to match the parameters. So if there all the parameters has the drought-like condition, then there is a severe drought. If one has severe drought, another is low drought or less drought or moderate drought, then it's come as a moderate drought condition. And other than that, that is in the no drought-like situation. So this for this year, there is no drought in India. I have used two parameters. One is MAI. MAI has some gap in the imagery. So this drought 1, as I added drought 1, that is for MAI. So you can easily see the gap in the image that is hollow. So our AET data and PT data has no value for that image, that area. So that's why our drought map is also has no area. If it is has the data in that rainfall or other, but in MA there is no value, so that is declared as, that is masked out from the imagery. So I have used again for the NDVI drought. So there is the same thing. See, recent and see, there is no drought-like condition in India. Green, yellow, and red. The green color shows the no drought condition. If there will be drought-like condition in India for using all the parameters, then it will become a red color condition. So for declaring the drought, we have to use all the parameters. So this is for monitoring the drought condition.
Just I would like to add, actually, these are the indices apart from which can for which we can use remote sensing data like rainfall, vegetation condition. We can use the remote sensing data. Some are coast data, like CHIRPS data is available at I think around 5 by 5 kilometer. Is it the case? What is the resolution of rainfall?
The rainfall is 6 kilometer.
5 to 6 kilometers. So
it's around
so
6 kilometers.
So it is just an example for because of actual declaration of drought. There will be many other crop condition. Then reservoir storage also there is a index,
Yes.
reservoir storage index. But
So this is
it
remote sensing based
come.
indices actually.
Yeah, it is remote sensing based indices and groundwater level also based on the level of the groundwater deviations from the normal value. There are indices and these are given. These are suggested indices in the drought manual prepared by Department of Agriculture and Cooperation. So she has just implemented the formula and see it as just an example. It is not like drought can be declared using
map of drought. It is just an example. Don't
yeah.
go with it for showing somewhere that this is the drought map of India.
Yeah, but it gives a very good indication how the vegetation condition you can monitor. You can implement using UI application. You can create application and you can monitor the drought periodically. You can monitor the condition of vegetation. You can also have a look on rainfall deviation. So it will give a better time for preparation for mitigation measures. So I think is this the one last code or are there many more?
Yes, sir. Yes, sir.
Okay, I think these are very good examples. Though I basically these are somewhat lengthy codes and some new methods which we couldn't cover in as part of the basics, but because I will ask Pragati and Ashutosh to revisit the code. You rectify whatever is there.
There is some error in this code. I
Yeah.
will check it.
And give the final version of the script so that we can share with the participants and so that they can have they can practice and they can think more about using other available data sets or for any specific small area they can upload their own image at a final resolution and then they can do the similar analysis. So I am very thankful to Ms. Pragati Singh and Mr. Ashutosh Singh for preparing this session on the application of Google Earth Engine in respect of flood monitoring and drought monitoring as well as agricultural crop crop monitoring. So we can, if there are any questions, queries, I think many participants have left us. If still there are any questions, I think they can pose. We can have 10 minutes. We can allot for questions. Even after that, I think they can post the questions in our WhatsApp group as well as in the classroom. Both the faculty members would be available. They would be answering your queries.
Yes,
Thank you.
yes, we will.
Thank you, sir.
Thank you, sir. Thank you, sir.
सर एक्चुअली ऑफिस टाइम के कारण ज़्यादा समय इसमें लगा नहीं पाए तो बाद में हम हेल्प
Sir, your voice is breaking, but I could get that you couldn't attend it fully. You are saying that?
Yeah. Actually, due to office work, time to time, I did not manage to adhere with the topics. That's why I am asking and I am requesting. Later on, we will get the help from you, no, sir.
Yeah, yes. Actually, those WhatsApp groups will remain, and we will be sharing the list of sessions along. You go in the same sequence. I will suggest to go in the same sequence so that you will get conversant with the platform first, and then you can have a look at these codes. These are lengthy codes. And we will always be there. You can post any query on the group, WhatsApp group. It may take some time for us to get back and attend the query, but you can post your queries even after completion of training program. However, for getting certificate, after the completion of training program, we will be circulating an assessment test, MCQs, multi-choice questions, and then a feedback form. That has to be filled by everyone, and those who submit the assessment test and feedback form we will also give sufficient time period, say 10 days to 2 weeks period after the completion of training program. You take your time, you see the sessions, you revise them, and you submit it. For us to give certificate, we will consider it as a successful completion of the training program for those who submit the assessment form and feedback form. Even afterwards, the queries can be posted. There is no issue.
Yes, sir. Thank you, sir.
Okay.
Thank you, sir. Thank you, sir.
If there are any queries, we can attend. Otherwise, we can conclude this session.
Good afternoon, sir. When will we have the assessment, sir?
Assessment on 23rd, after completion of the final session. Tomorrow we will have a break on Sunday. On Monday, we will be uploading 2 sessions. And Monday evening, we will circulate assessment test Google form. And you will sufficient time period will be given for completion.
Okay, sir. Thank you very much.
Sir.
Okay, then I think there are no queries.
Hello,
no
sir.
No other queries.
Hello.
Thank you, sir. Yes, yeah, please go ahead.
Sir, for flood inundation map preparing in Sundarban region, just this year's cyclone, but why forested area are not showing as a inundated area in Google Earth engine Sentinel-1?
Sir, your voice is not clear.
Sir, I think
you
he
said
is talking about some forest cover area with flood affected area.
Yes, ma'am.
The
In
forest
Sundarban,
area in Sundarbans, forest area in Sundarbans is inundated, but it is not shown on the imagery.
Yeah, actually, it is task for the trainees. I said earlier to the Chaitanya sir to give the task to the trainees to map the forest affected land use with the flood in their practical and post it on the Google Classroom.
But I think Sentinel-1 will also will canopy cover affect
Yes, sir.
the water pixel, means it will the
Yes, sir.
microwave
If there is a very sir, the land cover is very totally filled with the vegetation, like the height of the trees is very much higher in the Sundarban Delta. So it will affect the flood affected area.
So microwave data has also some limitation.
Yes, sir.
Especially if there is canopy cover.
Yes, sir. But we can change the polarization
Okay. In other bands, we can have even inundated area, even in forested areas, we can get.
Yes, sir. We can use a VH or HV band for that, but it will make some it has some volumetric information. It will not give us correct information, but it will provide us information related to that area.
Okay. I think ISRO along with NASA, they are planning NISA this year or next
Yes,
year. That will also add to the public data set. So in coming days, we will be having much finer resolution data sets, and more and more public data sets are getting available. So to deal with this big size means the data, this platform it will be of great utility. So basically, we want to give introduction to this platform and how to make use of it. And from here, you can attend more advanced training programs. You can do self practice. There are many help topics available online. Even the Google Earth Engine portal also. There are many examples.
And madam, one last question. Can we do spectacle filtering of Sentinel-1 in Google Earth Engine?
What filtering?
Spectacle filtering in Google Earth Engine for Sentinel-1 data?
Actually, your voice is not clear.
What kind of filtering, sir, you are talking about?
Sir, spectacle
Spectacle filtering.
I think he is talking about speckle filtering.
Speckle filtering regarding microwave data.
Yes.
Yes, sir.
I think, let me check. The data is uploaded in the Google Earth Engine. It is already like image classification and has been done for that. Like the speckle filtering, I think done, but you can do some kind of filtering kernel using. I think it is not available in GE.
And
It is not available.
okay.
Yes, sir. It is not
So-
available. You
Okay.
can use the snap for that if you want, because the already actually I forgot the term, but pre-processed. Yeah, actually pre-processed data is uploaded in the GE. It is pre-processed data. So for using the processing, like pre-processing, if you want to do the pre-processing of data, you have to download the actual data from Copernicus site and process it into Snap. And in GEE, the already pre-processed data is uploaded. That's why they have not provided this kind of things.
Okay, then I think we can conclude now. Thank you very much. Thank you to the faculty members as well as all the participants. Uh, we will be sharing the recording maybe by tomorrow. Okay, thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.